So hello there and welcome to another tutorial. My name is Sammy Bakshi and today I'm joined by Rich Hagarty. So welcome Rich, thank you for joining in today. Would you like to quickly introduce yourself?
Pleasure to be with you.
Thank you.
I'm Rich Hagarty, I work for IBM. I'm a developer advocate working on the Watson services. So our role, our team, we have a small team. We focus on the cognitive AI side of things. And our job is to create assets for developers.
Yes.
So we go and create actual applications that utilize a lot of the Watson services, and we provide a lot of information about how so developers can get started, a running start with pretty extensive READMEs and tutorials and blogs and all that stuff that we'll get into later on.
That's great.
That so that we get developers onto the Watson services as quickly as possible.
That's nice. Thank you very much. This is really interesting stuff you just mentioned. In fact, the tutorial today is all about the Watson Discovery Service, and more specifically, a new feature that's going to be coming to all Watson Discovery Service instances very soon. Now, that feature we'll talk about in just a moment. It allows you to get structured information and knowledge from your unstructured information, which is really interesting. But for now, I'd like to begin by talking about how we can actually use the Watson Discovery Service in a much easier way using the code patterns that enable you to create Watson applications. So Rich, would you like to tell us a little bit more about the Discovery UI that you've created as a code pattern?
Sure. So what we did was we took a real use case. We took, so first of all, Watson Discovery is great at ingesting unstructured data.
Yes.
And indexing it and adding its enrichments so that it can be queried in a number of ways. So that's the power of discovery. So what we did was we took basically 1,000 Airbnb reviews for the city of Austin. This is freely available data anyone can get.
Yeah.
So that's part of the behind most of our code patterns. We always use data that people can get for free. We have access to the services that they can get on a free trial basis.
Okay.
So users never have to pay for anything to get started, right? So our code pattern basically takes a look at that data. We can use the Watson Discovery tooling to look at that and try to get some information, glean some information from that. Through the tooling, a little bit ugly. The interface, just individual queries. It's not formatted very well. So what the UI did was just put a happy face around that using the APIs, making the same types of queries that users would typically make, presented in a nice UI so that people can see it and get some data information from it that way.
That's great.
Yeah.
All right, so now let's take a look at how easy it is for you to get started and actually use that new Discovery UI. And let's take a look at 1,000 Airbnb reviews and take a look at what kinds of insights we can glean.
Okay, so anyway, this is the developer code pattern homepage, which is available at developeribm.com. So this is where the landing page for all of our code patterns. So as a developer, this is where you'd come to you have a specific need, or you're trying to look for an example in a specific service. So you would come here to find that.
That's great.
So we have some filtering over here, or some hints to get you to where you want to go. I'm going to go directly to the app that I created. So for each one of these developer patterns, we have this nice page, overview page, which allows you to view a demo, try it out. You can actually run it without doing anything, just clicking the button, you'll get there. We have a description of the code pattern, overview. This is where you're going to determine whether you really want to dig deeper or not.
Yeah.
Hopefully, gives you enough information for that. As with all the code patterns, we have a diagram flow describing the services and the interactions between the pieces.
Yes.
So from there, let's go ahead and get the code. That takes us to the GitHub repo. Again, all of our code patterns are housed on GitHub publicly. They're freely open sourced, so people can take them and do what they want with them. They can actually contribute to the code if they find bugs. They can log issues, whatever. So I'm going to go to the GitHub repo here. First page is always a detailed README. So for this one, we talk about a little bit about what Discovery does for you. This is the enrichment part, what we talked about. where it pulls out entities, categories, concepts, keywords, and sentiment.
Yes.
And we'll dig a little bit deeper in how you set that up with your data. Here's that same architecture diagram.
Yes.
Where we're feeding JSON files into Watson Discovery. The API accesses that discovery, shows it to the user. Here's a little hand drawing of some of the layout of what it's going to look like. I thought this was pretty cool. This is what we thought about initially, what we wanted to show to the user.
Yes.
So these are all the UI components. So not only are we showing you how to access Discovery, but we're also going down and using specific. Obviously, we're writing code, so we have to choose a specific framework.
Yes.
So what we like about Node, this one's written in Node, and what we like about Node is that it's a little more freely open to other frameworks. It's not so cookie cutter.
Yes.
You have your choice of things. In fact, here we talk about all the components that this one uses. It's Node.js, based on React. We have an Express backend.
Yes.
This one uses semantic UI components, which is cool. It uses Chart and Jest for testing.
That's nice. So I can see that all the steps here are really neatly written out, which I love. So if I'm a developer that's just starting off with Watson Discovery, I wouldn't need to start from scratch and start from the documentation. There's a clear list of steps here that's going to help me out. So I like that.
Yeah, and you don't want code snippets, right?
Exactly.
You want fully functional code, and that's what we're trying to deliver. So we have a video which you can go click on. I encourage you to do that. And
there will be a link in the description.
Okay, good. And that's a deeper dive into this thing. So here's the steps you talked about. Now, for most of our code patterns, we offer a deploy to IBM Cloud button, which is a convenience. Basically, there's some setup involved. I would recommend users who really want to know this stuff to actually go through the manual process of downloading it locally, provisioning of the services yourself. That's the only way you're going to learn. But we always offer this option, which does the provisioning for you and pushes the code and deploys it on the cloud, and you can access it that way.
That's convenient.
Yes. So these are the steps I would recommend running locally. Starts with cloning the repo. Then we go through the creating of the IBM Cloud service. In this case, it's just Discovery. And we'll show you that in a bit, the end result of how that works. But essentially, you provision a Discovery instance, and you point to the data that you want to ingest.
Yes.
And this little GIF here takes you through that. And they get ingested into Discovery. So again, these are the steps involved with that. At the end of that, you're going to have a set of credentials that Watson provides for you. To run this application, you need to plug those into our env file.
Yes.
And basically,
the env file, just for those not familiar with Node.js, would be the environment file telling you all the different credentials.
Yes. So it's basically username, password, and the pointer to exact instance of Discovery we want to talk to. And then you just run the application. And it's available on port 3000. So let's go to let's go to the Discovery service. So here's those Airbnb ratings. I've already created the collection.
Perfect.
If we click on that, you'll see that we've loaded in 999 records.
Perfect.
One of the key things about the enrichment is done through a configuration file. So here's where you access that. And you notice here that for us, we want all of these enrichments to take place. Okay. Another concept that we're going to go into later with the knowledge graph is that we need to add the mentions to this configuration, which is not available in the tooling. So we had to do that programmatically through the API.
So if you take a look especially if you take a look at natural language understanding, you'll realize that under the entities, there's also a specific kind of, there's another enrichment you can add, the mentions. That's not available through the tooling currently, so you're going to have to add that manually, but we'll get into that in just a moment when we're talking about the new feature that I was telling you about, the knowledge graph.
Right. Perfect. So here's the data, and it pulls out things like top entities. These are what we call aggregate information.
Mm-hmm.
So it takes a look at all the 999 of them, and it pulls out the things that it finds most often.
Yes.
So we have related concepts, the hierarchies. So it's all cool stuff displayed to you. You can actually dig deeper, look at some of the actual fields that it pulls out.
Mm-hmm.
We can run queries through the tooling.
Yes.
Wish I had a nice query I can run. It's about Airbnbs in Austin, so I'm going to say near the college. Let's see what we get.
All right.
So we get some hits about from the ratings themselves. Again, this is not easy to read. It gives you scores based on how well Watson thinks it meets the criteria for your search.
Yes.
Those kind of things. So the whole purpose behind the UI is to make this more readable and accessible to the user.
Absolutely.
So let's go to the UI. So here it is. I'm running on port 3000 off that same data. These are all of the reviews. And notice we have those enrichments we talked about as filters.
So this is what you build with the code pattern. So when you
Yes.
actually go ahead, download the code pattern, run it with NPM, this is what you're going to get, a little UI for Watson Discovery.
Right. So these things are pretty obvious. It talks about the entities or the enrichments. Each category, it tells you the number of hits, what category it found. We have a nice tag cloud here with the top entities or any of the other enrichments you want to choose. We also have a sentiment chart. This is based on Watson's determination of sentiment, which is different than a rating. So the user has rated the facility, the Airbnb rental, but Watson has looked at the actual text and context of the wording of the rating and determined a positive or negative sentiment.
Yes, exactly. Not towards necessarily the actual place, but towards the situation that was described in the review.
Yes. And in this case, you can see most of them are favorable. We have a nice trending graph here so we can see how the term Austin has trended over time. I don't know if that's a very relevant one, but I'm just going to... Oh, it's the actual scores over time. So you can use different values here.
Yes.
Let's see if we get a good one here.
So now we can take a look at the concepts. There we go.
And of course, we can also, there's some other niceties here. We can filter the matches, the actual ratings we can show based on...
Let's actually go to the lowest rated. Let's take a look at a negative sentiment here. There we go. So as you can see, there are quite a few people that have negative experiences with Airbnb. But this one over here about South by Southwest says, Lisa was great, which is positive. Welcoming, cute bungalow, and good references for food around town. Okay. But this is where the negative part comes in. All right. When I broke a key, she came armed with bolt cutters and rescued my computer from the locked cabinet, above and beyond. Now, as a human, you can tell that this is technically positive. But Watson took the situation into context and said, hey, you broke a key, but luckily someone came armed with bolt cutters. But the situation generally here was negative. If this hadn't happened, it would be more positive.
Right.
That's why Watson gave it a negative rating. If you wanted to, say, make this more relevant to Airbnb and try and predict what someone's rating would be based off of the text, then in that case, you would probably have to train your own model either A, with the Watson Studio, or with natural language classifier, or something that you seem fit. But for the sentiment, this is what the sentiment understanding currently does.
Right. Great explanation. Okay.
Thank you.
So let's go back to discovery, and let's talk about how we can further enhance this data through building relationships and the knowledge graph.
Sounds good.
Okay.
All right, so now we can get a little bit deeper into Watson Discovery by taking a look at the knowledge graph. But wait, what does the knowledge graph do? Well, imagine this. For the Airbnb reviews, we've got people who are reviewing different places at Airbnb. Now, let's just say we wanted to extract some structured knowledge, some kind of facts that we're able to find from that text, and we want to be able to display it in a graph. Like, let's just say we've got Fiona. Now, Fiona is someone who actually hosts guests on Airbnb. Now, of course, these Airbnb reviews are from Austin. And so the place these are hosted at are, of course, Austin. We know that already, but if it weren't as obvious to us, like for example, if we were taking global reviews into account, we'd need information like this. Now, one more thing. Fiona is hosting people in downtown Austin. So downtown is technically considered as a separate location by Watson. And this is downtown in the south of Austin. So south is also a separate location. Now, this is how the knowledge graph works. All of this is in really complex, unstructured natural language. But with the knowledge graph, you can go ahead and determine relationships between all of these entities. We know that downtown Austin and south are geopolitical entities or locations. And Fiona is a person. And so, Fiona is located in Austin. Okay, so Watson is able to tell us that Fiona is located in Austin. Watson's also able to tell us that Fiona is located downtown. And then Watson can go even deeper and say downtown is located in Austin. And all of these relationships are being found from simply natural language. And then it also tells us that downtown is located in the south. And then all we need to do is build an algorithm that can understand this kind of graph, but much, much larger, of course, because this is only a small snippet of all the different knowledge that Discovery was able to uncover. And just like that, we can understand unstructured data through the Watson Discovery service using Knowledge Graph. Unfortunately, since it's in beta, it's only currently available to advanced and premium instances. So if you have an advanced or a premium instance of Watson Discovery, great, you can follow along. If not, then I'd highly recommend you take a look at how it works, just so you're ready when Watson Discovery has this feature rolling out to all the other kinds of instances as well. Alright, so now in order to enable the knowledge graph feature with your Discovery instance, you first of all have to give Watson the correct enrichments for it to be able to find out what should go in the knowledge graph. So what I'd recommend you do is you go over to the Watson Swagger interface. Now what this is it's basically the API Explorer for Watson. You can find it at the Watson API Explorer.ng.lumix.net, and there will be a link to it in the description below. Now, if you scroll down, you can see every single different kind of API call that you can make to the Watson Discovery service. There are lots of them, and they're really useful. But the one that we want to use is actually get your configuration. Now, your configuration is what tells Watson what exactly it does with different data sources and how exactly it enriches those data sources. So what you do is in the very top here, paste in your username and password for your Discovery service, then scroll down and provide your environment ID and configuration ID. Go ahead and click on Try It Out, and as you can see, it's going to run the request, and it's going to come back to you with a response. This is the whole configuration. Now go ahead and copy this response, and paste it into the update API call. Now, of course, you're going to need to copy in your environment ID and configuration ID, but you also need to paste in the configuration. And if you paste it in and you scroll up, you'll realize that where it says entities, you will not have mentions and mention types. So what you need to do is you need to add mentions true and mention types true. There will be a link to a GitHub gist that contains this whole configuration for you, so you don't need to put it in for yourself manually. And then what you do is fill out the environment ID, which I can just copy from up over here from our last call. Paste it into the update, then go ahead and do the same thing for the configuration ID, and then tell Watson to update that configuration. Of course, I haven't needed to add anything because I already had it there, but once you add in your mentions, just click on Try It Out, and just like that, you've updated your configuration. Response code 200, it's a success. Now, Watson knows exactly how it needs to enrich the data. Now, one thing you need to make sure is that you upload your documents after you do this step. Do not do this step later, because then Watson will not be able to re-enrich your documents. You're going to need to delete the configuration or delete the environment and do it all over again, or delete the collection.
Right.
Alright, so now that we're back here, and now, of course, we've already had our mentions in, Watson has enriched the data, now we're going to take a look at what the knowledge graph truly does. Now I'm going to go over to this pane over here, the build queries pane. Now, right beside search and aggregations is knowledge graph. If you don't see it, then that means you're not running a premium or advanced instance as of today, which is July 20th. So, now of course you can go ahead and find some different entities if you want to, like for example, well, let's just say I wanted to find a person called Fiona. I can go ahead and run the query, and it would give me entities that match that Fiona, and it gives me some information about that entity. But what's more useful and what you want are the relationships. Now of course it gives you, Watson Discovery is going to give you a list of all the different entities inside of its knowledge graph that it's built inside the system. And so all of these entities are related to other entities in some way or another. So now that we're here, let's take a look at what we can actually do. Now, let's just say we're looking for Fiona, and we want to see how exactly Fiona is related to Austin. All I'm going to do is run the query, and as you can see, it tells me Austin has a co-location with Fiona. Co-location is a very, very broad sort of relationship, so we can ignore all the co-locations. But Fiona is located at Austin, and Fiona resides in Austin, and both of these are correct. So I can actually go ahead and take a look and remove Austin. Now, if I only provide discovery with Fiona, and I don't tell it to find the relationship of Fiona to any other specific entity, then it's just going to give me all the relationships that Fiona has to other entities. There's Brian, communicate. She's the owner of a cottage. She greets people that come over. She's located at location, which is a co-reference to another entity. But these are all the different relationships associated with the Fiona entity. Now, if you were to actually go ahead and take all these relationships and graph them out, this is what it would look like. Now, one thing I would like you to note is that I'm using a website called webgraphviz.com. And what I did is I actually just went ahead into the JavaScript console of Google Chrome, and I put together a quick, like a three-liner piece of JavaScript code over here. And basically what this JavaScript code does is it allows you to take all these relationships that are shown in the Watson Discovery tooling, and as you can see, it exports them to a format that GraphViz likes. So you can go ahead and copy this, and you can paste it into GraphViz, and that's actually going to make a really neat knowledge graph out of it. So I took a few different entities, namely I took Fiona, downtown Austin, and I took those three entities, and I found all the different relationships they have, and I exported them to GraphViz format, and I put them into this website called webgraphviz.com, so I didn't need to do it manually in Python. So as you can see, this is the whole graph that it makes for us. Let's go through this a little bit and take a look at what it actually is. So, of course, we have Fiona at the very beginning here. Now, Fiona is located at location. Of course, that's just a co-reference to another entity. She's the agent of recommend. And she's the owner of a cottage. So you can see Fiona, owner of cottage. And there's another feature in Discovery that allows you to find evidence for these, but we're not going to be covering that in this video. Now, there is a little bit more of an interesting map here. So if you take a look at Fiona, she's located at downtown. Now, Fiona is also located at Austin. Now, downtown is located at Austin, and downtown is located at South, and South is also located at downtown. So there's a sort of circular reference here between these two entities. Now, if you take a look over here, there's also an organization called Congress that's based in and is a part of the South, which is located in downtown, which is located in Austin. So as you can see, you're able to create these really complex graphs. You can take a look at Congress, and you can see that Congress is technically located in Austin because Congress is based in South, which is located in downtown, which is located in Austin. So you can make these really complex relationships. You can also take a look at some more things that are located in downtown. Like, for example, Hyde Park is located in downtown. There's a neighborhood. There are many restaurants inside of downtown. There are the buses, streets, cars, they're all in the downtown. And so, as you can see, this is just a small fraction of the knowledge that Discovery was able to extract from the Airbnb reviews. And again, the Airbnb reviews weren't even written with the intention of providing this kind of knowledge, but still Watson Discovery was able to understand that natural language and provide that information to us. But we've got a little bit more of an interesting data set that's meant to actually provide this kind of knowledge. Now, this data set is actually 2 documents, just 2 documents, in contrast to the 999 available over here in the Airbnb ratings. However, if you go back over to manage data, it's a very, very interesting data set. See, the data set I'm talking about, 2 biographies of Henrietta Lacks. Now, just in case you're unaware, Henrietta Lacks, actually suffered from a kind of cancer back in around the 1950s. And this kind of cancer was actually special because the cancer she had made her the first person to have cells that would live and actually thrive outside of a human body. So you can actually buy HeLa cells, as they're called, and actually run experiments on them. And so that's why we've solved, or not necessarily solved, but we've had major breakthroughs in different areas like cancer, tons of different kinds of areas because we were able to use those different cells. And so, of course, there are quite a few different people who write biographies on Henrietta Lacks. And so, we take these biographies, more specifically the one by Rebecca Skloot, and also the Wikipedia page on Henrietta Lacks, and upload them into Watson Discovery using that same Airbnb config so that we have the mentions and the entities and the relationships all in the configuration. As you can see, it tells us that it's 50% positive, 50% negative. It gives us some keywords: Henrietta Lacks, Babette Lacks, Carter A. Personal, Crownsville State Hospital, David Lacks, and these are all related to, of course, the biography. It tells us a little bit about the content, and it also tells us about a few different concepts. Of course, HeLa, as I was mentioning, the HeLa cells, talking about cell cultures, Rebecca Skloot, who actually wrote the biography, and Henrietta Lacks herself. But I know what you're interested in. You're interested in the knowledge graph, so let's head over to the knowledge graph. Now, let's just say that we wanted to find the relationship, all the relationships that Henrietta Lacks has. As you can see, these are all the different relationships that Henrietta Lacks has. Now, Henrietta Lacks has attribute cancer health condition. Watson's able to find these really complex relationships just from natural language. And then the best part is that you can combine it with other machine learning services to say, hey, something like, does Henrietta Lacks suffer from cancer? And actually convert that to actually find a certain kind of attribute or entity in this knowledge graph. But anyway, let's just say I go ahead, inspect, and I run inside of the console that quick 3-liner of code I was telling you about. As you can see, we get these GraphViz entities, or this sort of GraphViz format text. So if I were to copy that into Web GraphViz again, as you can see, this is the knowledge graph it gives us for just a few of the entities inside of this knowledge graph. Of course, there's a lot more you could extract if you wanted to, but this is what I've extracted for now. So as you can see, this is actually great because it says Henrietta Lacks, part of many, elderly, because Henrietta Lacks was elderly. Henrietta Lacks is also the parent of Deborah Lacks, which again is correct. Henrietta Lacks also resides in Clover, which is a geopolitical entity. Now, Deborah Lacks is even more interesting. Oprah Winfrey actually plays the role of Deborah Lacks in a movie. However, Whispers is not the name of that movie. That's a separate entity altogether. And Deborah Lacks is also part of many descendants. And these descendants of Henrietta Lacks are located in the South, just like Deborah Lacks is located in the South. And she's also part of the family, the Lacks family. And she's also the agent of informs because she's informing people about this by participating in talks. All the descendants are participating in talks, as well as Deborah Lacks. If you go over here, here are some entities that aren't actually directly linked to this part of the knowledge graph. However, if we were to get out every single relationship in this knowledge graph, there would probably be some kind of link here. Now, again, this is why this is so interesting. We can see that there's an instructor, which is a person, who's employed by Bellarmine University, which is an organization, and this organization is based in Louisville, which is a geopolitical entity. Now, Centre College is based in Danville, and both Danville and Louisville are located in Kentucky. So they're both located in Kentucky,
Yes.
as Rich tells me. They're both located in Kentucky. And so this is the knowledge graph that Discovery built of just a few entities. Imagine having to go through that entire biography as a human and actually having to extract these kinds of relationships, make notes about this. Now, instead of you actually reading through all that text and actually having it be impossible for many computer programs to go through that text, you can use programs like Watson Discovery to create knowledge graphs, convert it to structured information, take a look at all the different relationships that exist inside this text, and of course make your life a million times easier by converting unstructured data into structured data that you can make use of in your algorithms.
Yeah, great job explaining that, and I think this graph really drives it home. So that's great.
Thank you.
It's a nice feature.
Very soon we should create a code pattern once the Watson Discovery knowledge graph is in, of course, it is completely available to the public, because currently it's only in advance, and the code pattern should allow you to upload documents and automatically make huge knowledge graphs like this one that you can actually traverse in 3D. That would be an interesting code pattern.
Yes. Looking forward to it.
Thank you. All right, and so that's how you can use the Watson Knowledge Graph, or the Watson Discovery Services Knowledge Graph, to convert unstructured data into structured data. All right, so that's how you can use Watson Discovery's new Knowledge Graph feature. Hopefully very soon it becomes out of beta, and you can use it in your free trial instances, your light instances, and your regular instances as well. So thank you very much, Rich, for joining in today. Glad to have you on the show.
My pleasure. It's been a great opportunity working with you. Appreciate it.
Thank you very much. Glad to have you on. So apart from that, if you did like the video and you want to see more content just like this one, please do consider liking the video and sharing it with people you believe may be able to benefit from it. Apart from that, if you have any questions, suggestions, or feedback, please do go ahead and contact either Rich or I. So Rich, how can people contact you?
Probably my personal IBM email account, which I think you'll provide a link to in your video.
Perfect. So Rich's email address will be down in the description below. Also, my email address, my Twitter, will be in the description. So if you'd like to ask Rich or I any questions, please do feel free to contact us, or even just leave a comment down below, and we'd love to get back to you. Apart from that, if you do love the videos on this channel and you want to see more content like this, please do consider subscribing as well and turning on notifications so you receive an email every single time I upload a new video. So thank you very much, and thank you, Rich.
All right. Thank you.
Thank you. Bye-bye.
Bye-bye.